Welcome everyone to the channel Propulsion Science. Today in this lecture, I myself Abhishek Shende and my friend Saurav Kumar will be going to discuss the topic to you, that is diesel engine and Otto cycle. Here in this video lecture, we will be discussing about the diesel engine, its stroke cycles in detail. So without further wasting much time, let's get into the topic. So before understanding about the cycles, we should know what actually a diesel engine is. A diesel engine is a type of internal combustion engine that uses 4 piston stroke cycles to complete one power cycle. So what are the stroke cycles? The first one is intake stroke. The intake stroke is a cycle in which the piston moves downward, drawing air into the cylinder. As you can see in this visual description, that the piston moves, when the piston moves downward, the air comes inside the cylinder, and then occurs the compression stroke. When the piston moves upward, compressing the air within the cylinder, this stroke is known as compression stroke. After the compression stroke, there is a very crucial stroke in the stroke cycle, that is power stroke. In this power stroke, the fuel is injected and the air fuel mixture ignites, causing a control explosion inside the cylinder. Due to this explosion, this power stroke helps in further giving further power for upcoming strokes. Then comes the exhaust stroke. In this stroke, the piston moves up, forcing the exhaust gases. When the exhaust strokes occur and the piston moves upward, the exhaust valve open and the gases inside the cylinder moves outward and releases from the cylinder. Then comes the intake stroke. Here in this video, in this slide, we will be discussing in depth about the intake stroke. Intake stroke is a first step in the 4-stroke cycle, which is the process that a 4-stroke diesel engine uses to complete one combustion cycle. Actually, an intake stroke is a start of stroke cycle. When the crankshaft rotates clockwise and the piston moves down from top dead center to the bottom dead center, the intake valve get open. As you can see, when the piston is at bottom dead center, there are some air molecules inside the cylinder. These air molecules enter the cylinder when this intake valve opens. Uh, the piston moves downward and create a vacuum, which helps in uh, resulting the air inside the cylinder. Then comes the compression stroke. The compression stroke starts at the end of the suction stroke or at the bottom dead center and ends up at the top dead center. The inlet valve closes and the piston moves upward towards the top dead center and compresses the air fuel mixture. The air is pressurized by the crankshaft and flywheel, and the pressure and the temperature increases the combustion levels. Thank you.
So the third stroke is power stroke. The power stroke, also known as the combustion stroke, is the stage in a 4-stroke diesel engine when the compressed air mix ignites and expands, force the piston down in the cylinder. So after compression, the fuel injector sprays the fuel in the cylinders, which ignites the compressed air and forces the piston to move down. So the fourth stroke is the exhaust stroke. The piston moves back up the cylinder from bottom dead center to top dead center. This action forces the suspended air and fuel mixture out of the cylinder as hot gas through the open exhaust valves. The shaft rotates 180 degrees and the inlet valve remains closed. The piston approaches the TDC, the inlet valve opens and the cycle begins again. Now we have the Otto cycle. This is the PV diagram which shows the difference in pressure and volume during the process in the cylinder. So process 0 to 1. This is the intake stroke. The air at constant pressure is drawn into the piston cylinder. Now the process from 1 to 2, the piston move from BDC to TDC, compress the fuel and air in the adiabatic compression. In process 3 and 4, the heat is transferred from the external source at a constant volume to the charge while the piston is still at TDC. Now from 3 to 4, when the mixture burns, it expands adiabatically. This is called power stroke. Now from 4 to 1, the heat is rejected from the air at constant volume at the end of cylinder. Now from 0 to 1 is the exhaust stroke. It releases the mixture to the atmosphere.